So now what we want to do is we want to discuss the relationship between magnetism on the sun and sunspots. Because we saw there's a correlation in there. And the key has to do with how things move inside the sun. So deep inside the sun, so we have imagine we have the edge of the sun here, and we got magnetic fields going through the sun, so in some kind of fashion. So we have the magnetic field. When magnetic fields are produced, they're produced by moving electric currents or moving charged particles. In a similar way, magnetic fields exert forces on charged particles. That's actually how electric motors work. You have charged particles moving charged particles, so that would be the electric current in the motor, and the magnetic fields exert torque and turn the motor. So Babcock and Leighton, and they had done several other sort of things together in astronomy and stellar astrophysics. They were also instrumental in luminosity class, some of the luminosity class studies. But they came up with a study of the sun also. And so one thing that they did was they said, okay, we have a magnetic field. So the magnetic field goes into the sun, goes through the sun, and then comes out the sun. Well, charged particles act on magnetic fields as well. So all these charged particles in the sun, because the sun's very hot, so it's partially ionized. And so these charged particles going to the sun tend to trap some of the magnetic fields in the sun. And so the magnetic fields get caught up in these charged particles. And so as the middle of the sun rotates, or the equator rotates a little bit faster than the polar regions, then what happens is that the magnetic field, which is going straight through the sun pretty much, gets dragged forward farther and farther and farther, and then starts wrapping around the sun. As it wraps around the sun, it gets wrapped tighter and tighter and tighter. When you make it tighter and tighter and tighter, then what happens is that you start building these magnetic bundles inside the sun. And so here's the surface of the sun up here. These magnetic bundles are going to the sun. But then what happens is that you have all these magnetic bundles in the sun, and then, again, surface of the sun, the magnetic bundles coming through the sun here they get so intense that the gases don't move. So you have convection trying to happen in the sun, and those bundles get in the way. So what will happen is the convection will sometimes push some of these bundles up out of the sun. Now again, the gases don't move here, so where the bundles arch through the surface of the sun up here, the gases aren't moving, so they cool off, but instead of sinking back in the sun, they hang there, and so you have a couple little cool spots. Well, that gives you sunspots. So the sunspots occur right where these bundles are going through the sun. And you have a preceding spot and following spot. The polarity of the sunspots is that the sunspots that are ahead are a little bit closer to the equator than the ones behind, and so the sunspot group has a magnetic field that's almost opposite of the orientation of the rest of the sun. That turns out to be very important because that magnetic field is reversed from the magnetic field of the sun. Sometimes when you have these arching magnetic fields, then things can get stuck in there. What kind of stuff? Hydrogen, of course. So hydrogen gas gets stuck in there, and that gives you a prominence. And so that prominence looks like it's a big flame there, but there's different kinds of prominences. We have active prominences and quiescent prominences. The quiescent prominences will just hang there. Okay. And so quiescent prominences can last for weeks and sometimes even months. Active prominences are much shorter. They last for minutes or hours. So what happens is with an active prominence, it looks like a giant tongue of fire sticking out from the sun. What's really happening is that you have gas up here that's giving up energy and falling into the sun. And when it does, that causes gas above it to give off energy and fall into the sun, and gas above that to give off energy and to fall in the sun, gas above that. And so what happens is the bright glowing patch, which is where it's giving off energy, gradually starts moving outwards, and so it looks like a big tongue of flame sticking out from the sun. It's really stuff that's raining into the sun. Now, this is an active prominence. An active prominence sometimes happens in the presence of another thing that we call a solar flare, but it doesn't have to. Often you have even solar physicists will sometimes mistakenly refer to a prominence as a flare. It's not the same thing. So prominences are distinctly different sort of things, even though the active prominence can be triggered. So here we have a picture of the sun. You see this is an H alpha, so you see the chromosphere. You see spicules down here sticking out. You see a big prominence hanging out over here. You see smaller prominences around the edge of the sun. So this is the sun at a fairly active moment right here with lots of prominences all over it. If a prominence happens to run along the edge of the sun, it sticks out. But if it's running across the middle of the sun here, then it blocks the light of the sun below it and leaves what looks like a dark line across the sun. We call that a filament. So a filament is just a prominence that's blocking the light of what's under you. A prominence on the side, you can see it glowing because it's glowing against the blackness of space on the side. Some of these prominences stick way out into beyond the rest of the chromosphere into the corona, and we call those coronal loops. And they can be quite large. This image right here shows coronal loops with the sun drawn, with the Earth drawn to scale, to give you an idea as to how big these coronal loops actually are. Okay, the bright areas here in this image right here are the plages. These plages are bright regions in the chromosphere, and they typically lay on top of or above sunspot groups. That tells you there's a lot of something going on, magnetic activity, magnetic energy at those sunspot groups. And again, here's a big flare, prominence sticking out here from the edge of the sun right here. Okay, another prominence. This is actually an active prominence caught in the process of looking like it's leaping out from the sun. Really, it's gases that are falling into the sun. Okay. This is again a recent image of the sun, and you can see there's not a whole lot going on right now. There's a couple of prominences right about there, and that's really about it. But this was an image of the sun from last fall. That's actually a little movie right there showing an active prominence. And so again, it looks like that's a bunch of fire leaping out of the sun, but it's really stuff falling into the sun.